Hey guys, Mr. Algebraic here. In this video, we're going to look at algebraic combinations. So if the functions f and g are continuous at an x value of c, then the following combinations are also continuous at x equals c. And the first one is a sum. So if you add two continuous functions together, then their result will also be continuous. Similarly, a difference. So if you take a continuous function and subtract another continuous function, the result is still continuous. Products, so multiplying a continuous function times another continuous function, again, still continuous. Then a constant multiple, so if you took a continuous function and multiplied it by just some constant value, it's going to stay continuous. And then also a quotient, so f divided by g, as long as g of c, so if you were to take that c value and plug it into the function g, as long as that value is not 0, because that g function is on the bottom of your fraction. Composites of continuous functions are also continuous along every point at which they are defined. So if you were doing f composed with g, or the other way around, g composed with f, that would also be continuous. So if we're looking at a couple of functions, let's say our f of x function is the sine of x, and our g of x function is x squared. Well, if we think about a sine graph, that sine wave, that's continuous for every single x value. And if we think about a graph of a parabola for that x squared, that's also continuous for every single x value. So composites of these are also going to be continuous. So if we did f composed with g of x, that would be the sine of x squared. That's going to be a continuous function since it's built from two other continuous functions. And if we went the other way as well, g composed with f of x, which would be the sine of x squared, or we could also just write that as sine squared of x. That would also be a continuous function, again, since it was built from two other continuous functions. Similarly, if we had our f of x function being the absolute value, that function is continuous for every single x value. And if our g of x function was a cosine of x graph, again, that's continuous for every single x value. Any composite of those would also be continuous. So f composed with g of x, which would be the absolute value of the cosine of x, that's going to be a continuous function. Or if we went the other way around, g composed with f of x, which would be the cosine of the absolute value of x, both of those are also going to be continuous functions. So in this example, we're going to show that y equals the absolute value of x times the sine of x all over x squared plus 2 is continuous. And the way we're going to do that is by looking at it as a composition of functions. So let's say this was some g composed with f of x function, and that gave us this absolute value of x times the sine of x over the x squared plus 2. Now, if we wanted to try to define what our f and g functions are, what we could look at is kind of the bigger picture. I see this absolute value happening here, so maybe that g of x function was just the absolute value of x. And then if we kind of think about plugging some stuff in for x in there, maybe that f of x function was that whole fraction, x times the sine of x all over x squared plus 2. Now, we already know that g of x, that absolute value function, is continuous for every single x value. So we're going to spend most of our time talking about this f of x. Well, if we just look at kind of the numerator and denominator separately, having x times the sine of x, that would be a continuous function because there are no discontinuities. There's really no domain issues there that we would have to worry about as far as that x value. And also that x squared plus 2 on the denominator, that's going to be a continuous function because that's just the graph of a parabola, so we can plug in any x value we want there. Now, as far as making that fraction, we said that the fraction would be continuous as long as the denominator is never 0. And if we think about it here, the only way that we could have this denominator being equal to 0 was if x squared somehow equaled -2. But there's no x values that you could ever square and get -2 as your answer. So this fraction is in fact a continuous function. That g of x was a continuous function. So because this function that we started with, that y equals function that we started with, we made it from composing these two f and g functions. Since these are continuous, that composition will also be continuous. That's going to be it for this video. Thanks for watching.